All right, hey, we talked about intermediate value theorem on the first video. So now let's put it into context. Let me move this camera. I just realized I just moved that. So let's put it into some context here. Example 1, the function f of x is continuous on the closed interval from 3 to 9. Get a pen going here. On negative 3 to 9. That would be like our a and b that they talk about in the theorem. And then with an f of negative 3 equals 0 and f of 9 equal negative 12, this would be like an f, it's not writing, f of a and the f of b. And which of the following would be a correct statement concerning the existence of the value c by the intermediate value theorem? So I know that there should be some c that lies between negative 3 and 9 if my k value was between the f of b and f of a values. So my k has to sit between, oops, not b, but negative 12. Oops, let's rewrite this. I need to look at my numbers first. We want negative 12 less than k, which is less than 0. So what I'm looking for, I'm scanning for numbers first off that are between this, because that's the if part of the IVT. If it sits between there, then, and I have a continuous function, which we do, then I can be guaranteed there is a c value that lies between negative 3 and 9. All right, so these are the values I am first scanning. And I find that there are some that are outside the negative 12 to 0, such as 1 does not follow in that interval, and 0 is not less than, k would not be less than 0, it'd be equal to 0. Negative 13 would be sitting down here, so that's not in. Negative 10 could be a good k value, couldn't it? And if that's the case, then it guarantees that there is a c that sits between negative 3 and 9, and they're suggesting the c, oops, I didn't write out as a c, the c value is negative 2. Sounds good. I'm going with c. So you need to know these theorems very well. You need to know what the if statement is, what is the hypothesis of the theorem, and then that leads you into your conclusion. Next page. Example 2. Use the intermediate value theorem to show the polynomial function has a 0 on the interval. Yeah, the IVT can be used to show that there is a 0. Essentially, what I must show is that I have an f of a and f of b on each side of the x-axis, because then there is an intermediate value of a k being 0 to be located on the x-axis. I just want to put a spot, right? So then k is between my f of b and my f of a. So how do I go about proving that? Well, what I'm going to do is take their endpoints. Remember, this is a and b. It's the domain of our function, and let's take and examine that. So let's do f of 0. Putting it into the f function would give us 0 cubed plus 2 times 0 plus, minus 1. So we're getting negative 1 there. And then I'm going to do f of 1. Since this one was my negative number, I'm hoping my next one comes out to be a positive number so that it resides above the x-axis. And let's check it out. We're going to have 1 plus 2 minus 1 equals 2. Awesome. So essentially, we kind of have this, right? We have f at 2, at negative 1. My picture, I did not intend that to work out so well. Now, that means there must be, if I have a continuous function, there's my continuous function, that it has to cross the x-axis somewhere along there to move from -1 and finish at a height of 2. So yes, use the mean value to show that. So I would have this information provided because we have to show that an f of x is a polynomial. They gave us that information. I would write out polynomial. And that leads me to the conclusion that my function is continuous. And I got a continuous function with a k, let k equal 0. Then I have a value where k sits between f of a and f of b. Therefore, by the IVT, there exists a 0. On, need to repeat that, on this interval. On the interval 0 to 1. Perfect. All right, now the last one, 2007, the AB, they gave us a chart. We got F, F prime, G, G prime. You don't even really understand what those notations mean, so I'm going to guess that for this problem, you don't need to know that. The functions F and G are differentiable and continuous. We'll learn soon that if it's differentiable, it automatically means it's continuous, so this probably was not in parentheses, but we can conclude that. For all real numbers. And G is an increasing, strictly means that it's never ever going downward. It's always increasing as you move to the right. The table above gives values of the functions and the first derivatives at selected values of x. The function h is given by, right there it is, isn't it? By f of g minus 6. And explain why there must be a value r such that r lies between 1 and 3. So I know what my AB interval is. My AB interval is 1 to 3, isn't it? And I want an r that sits between there such that h of r equals -5. This is like my k value from the theorem. So I would have to say h of r is a continuous function, and it is continuous because it's a composite of two other continuous functions, right? It is a composite function built from two continuous functions, is a continuous function. And let where k equals -5 and h of 1 equals, h of 1 is going to be f of g of 1 minus 6. And g of 1 is 2. So I have f of 2 minus 6. Which equals, f of 2 makes a 9 minus 6. I'm getting 3 for h of 1. Now let's also find our other y value, h of 3. H of 3 will be equal to F of G of 3 minus 6. G of 3 is 4. So now this generates F of 4. I'm writing that just to make it a little faster. F of 4 is negative 1 minus 6. So I'm getting H of 3 equals negative 7. Okay, so when I think about the IVT, I want to go back to IVT, I need to show, oops, one too many. I need to talk about the fact F is continuous, closed interval, and K sits between F of A and F of B. Then there is a number C, or they're saying an R, such that that is true. So back to our problem. Just wanted to show you where all this is coming from. So now, K does lie between, doesn't it? Where K equals negative 5 and K is between, maybe a cursive K. For some reason, my screen is really behind my pen, so it's making it tough right now. Negative 7 and 3, which means I have F of H of 3. H of 3, which is less than K, which is less than H of 1. So the IVT, the intermediate value theorem, can be applied. Okay, and since the IVT can be applied, then we are guaranteed that there is an H of R that's equal to negative 5. So I kind of talked out that last little bit. Hopefully that makes sense, and you will get some more practice on this skill builder worksheet. So that's where you're headed next to work through the intermediate value theorem and get some more experience with it. Have a good day.